Now, we can use the ratio test on some complicated looking series. Let's take a series where I'm adding up all the fractions of the form n to the power n divided by n factorial. So I start at 1 to the power 1 divided by 1 factorial, and I add to that 2 to the power 2 divided by 2 factorial, and so on. Does this series converge when I try to add up infinitely many things? I'm going to use the ratio test. And the reason I'm going to use the ratio test here is because my numerator and denominator are going to play very nicely here. So I'm going to be looking at a numerator of n plus 1 to the power n plus 1. And I'll have a corresponding denominator of n to the power n from the previous term in the series. I'll have a numerator of n factorial, and I'll have a denominator of n plus 1 factorial. Again, this is after I handled my fraction division. So we can rewrite this, factor out an n plus 1 from the n plus 1 factorial, factor out an n plus 1 from the n plus 1 to the power n plus 1. And now this looks like n plus 1 to the power n divided by n, right? So I'm just canceling like terms. Factorials cancel, the n plus 1s cancel. What is left over but n plus 1 to the power n divided by n to the power n. And in the limit, that will go to the special number e, as you might have seen in a previous calculus class. So since e is a positive number, but it is bigger than 1, this series will diverge. So this will be a divergent series. I figured it out just using my ratio test.